decreasing inversely. It's rectangular hyperbola. Therefore, field is maximum on the surface as told by the equation as well as told by the graph. Your answer is coming to be what? Options is coming to be second option, that is becomes paramagnetic. Okay. So in that point of view, at higher temperature, preferably above Curie temperature, ferromagnetic feature will be lost. They lose domain feature. So that statement is also correct. Both the fields are in what direction? Both the fields are in same direction. Therefore, opposite direction. One is towards P, other is towards Q. We have to calculate net. Net will be 3 mu 0 I 4 root 2 R. Good morning, all of you. In today's discussion, we included 3 chapters. The questions asked in JEE Mains 2026 January session. The chapters included are magnetic effect of current, magnetism, and electromagnetic induction. Okay? Listen. Now, question number 1. A long cylindrical large cross-section carries electric current distributed uniformly over its cross-section. Magnetic field due to this current. Listen, so I told you yesterday that to make our explanations of taking less time, the explanations are coming on the board. Explanations are given. I just explain it. That's only. Look, magnetic field due to a thick conductor. Thin conductor, you know, mu 0 I by 2 pi r. This is a thick conductor. We have 3 cases. At any point inside, mu 0 I r by 2 pi r squared. So in first one, we can say that magnetic field inside is proportional to r, linearly varying with r. This makes that the magnetic field is 0 on the axis because r is equal to 0. R is equal to 0 on the axis, magnetic field is 0. Then we come to the surface, it will be mu 0 I by 2 pi r, because better to say capital R, because capital R is equal to small r is equal to capital R. And for any point, this is outside current. Outside point, it is inversely proportional to R. Okay. And at surface, small r is equal to capital R. Therefore, B on surface will be mu 0 I by 2 pi r. Okay. And it can be even given in a better manner if you draw a graph of it. Magnetic field on y-axis, radial distance from axis on x-axis. This is periphery, r is equal to r. Inside field varies linearly. Outside field is decreasing inversely. It's rectangular hyperbola. Therefore, field is maximum on the surface as told by the equation as well as told by the graph. Your answer is coming to be what? Options is coming to be second option. That is correct answer is D only, minimum on the axis. That is correctly 0 on the axis. Now we come into the next question. Tell me, magnetic field at the center of a current carrying circular loop is R, 16 microtesla. Then magnetic field at a distance. So we have a ready-made formula, we are using it. Again, come to the explanation. You know, at the center of circular coil, mu 0 I by 2 pi r, and at any point on the axis, distant x is this. we have to put x is equal to root 3 by r. When you substituting it, we are getting the value on the axis is equal to mu 0 I by 16r. 16r. Or, you know, on surface it is what? Mu 0 I by 2r. This is 1 by 8 into mu 0 by 2r. 1 by 8 into field at the center. 16 by 8. That is equal to 2 microtesla. Answer is 3. Answer is 3. Okay? Answer is 3. Now, it is better for you to remember, you make a relation. What relation you are making? B at any point on the axis. I'm going to write it as, look the formula, mu 0 I capital R squared divided by 2 into R squared plus X squared whole to the power of 3 by 2. You can do one thing. You can pull out R squared out of the bracket. So it is coming to be mu 0 I capital R squared into R squared will come out of the bracket as R cube 1 plus X square by R square whole to the power of 3 by 2. And simplifying, mu 0 I by 2r will come. Mu 0 I by 2r. And what is mu 0 I by 2r? Mu 0 I 1 r squared get cancelled. R cube there. It will be mu 0 I by 2r. That is b at the center divided by 1 plus x square by r square whole to the power of 3 by 2. If you can remember this formula, it will be very convenient for you. Once again, magnetic field at any point on the axis is equal to magnetic field at the center of circular coil divided by 1 plus x square by r square whole to the power of 3 by 2. Here x square is root 3r. So root 3 square will be 3r squared, isn't it? Therefore, this will be 1 plus 3, 1 plus 3, 4. 4 to the power of 3 by 2. 4 to the power of 3 by 2 means root of 4 cube, root of 64. That is coming to be BC by 8. BC by 8. So your answer is, how much it is coming? 16, BC 16 microtesla. 16 by 8 it will be 2. You can get the answer in a further easy manner. Okay. Now come to the question. Here I'm not going to the explanation. Explanation is not given with mathematical support in the question. We can do it. Now tell me P and Q, separation between them. Force per length or force between any two current carrying conductors is given by mu 0 I1 I2 2 pi r into length under consideration. Now force between P and Q, currents are in opposite direction. The force will be a repulsion. Force will be repulsion. Force is given by mu 0 is 4 pi into 10 to the power of minus 7 into 1, 3 into 1 into 3 into 1. I1 is 3, I2 is 10 to the power of minus 7. 3 into 1 divided by 2 pi. R is 3 centimeter. And you know, in numerator there is an L coming. If L and R are taken in same unit, that doesn't make any change in the actual value. So don't convert it into meter. The separation R I am taking in centimeter, length also I can take in centimeter. So I take 15. Now this get cancelled. Now tell me, this 3 get cancelled. What is left over? Force will be 3 into 10 to the power of minus 6. And this is repulsion. So this will be towards, force will be repulsion means towards the side of Q. Or towards R. That is towards Q means towards R. Because on the other side there's 2 because we have given in terms of R. R and P. So better towards R. Okay. Force between P and Q. Similarly, force between Q and R. Same manner, 4 pi into 10 to the power of minus 7 into 1 into 2 divided by 2 into 15. That comes to be same result, isn't it? This 2 get cancelled. This is 15. 2 pi into 2. Separation is 2. 2 pi, 4 pi get cancelled. Again, this is also coming to be 3 into 10 to the power of minus 6 Tesla. Here both are in same direction. Current is again attraction. So force on Q by R, that is an attraction, that will be also towards R. Okay, attraction means I'm talking about the force on Q. First case, force on Q by P was repulsion. P will push the Q away from it, that is towards R. Second case, current in Q and R are in same direction, they will attract. So when I'm talking about Q, Q will be attracted by R, force will be towards R. So both the forces are equal in magnitude. How much? 3 into 10 to the power of minus 6 Tesla, and both are towards R. The total will be 3 plus 3, 6 into 10 to the power of minus 12 Newton, minus 6 Newton towards R. Okay, so that will be the better explanation. Okay, yes. So they are given just formula only, they didn't go for the calculation part. Now we go to the question number 4. Two identical circular coils carrying current, and one thing, a person looking from O, current in P is clockwise, similarly current in Q also clockwise. Okay, that is further I am telling. Current in P is I and current in Q is 4I. Looking from O, currents are in clockwise direction. Now, better to go to the explanations, you can save time. Now, we have seen that formula for force, we have already told, mu 0 IR squared. Yes, separation between them is given to be R. So, force is coming to be mu 0 I 4 to R. Isn't it? 4 to R. And, you know, as far as point O is considered, from looking from point O, the current is in clockwise, magnetic field is getting into it, that is towards P, that I am marking here. Magnetic field, because looking from O, current in Q is clockwise, and when you calculate it, instead of small r we are putting, instead of x we are putting small r, that comes to be mu 0 I by 4 root 2 r, and this is towards P. Now, same explanation here, it will be again looking into it, magnetic field is getting into the coil Q, that field is towards right, that is towards the direction of Q. These are the direction. Now only one thing, in second coil, in the coil Q, only one difference is that current in coil P was I, current in coil Q is 4I. Only difference is that current, others are same, distance is same, everything is same. So two aspects, one, current looking from O is clockwise, magnetic field is getting into the coil Q, that will be towards right, that is towards Q, number one. Number two, current is 4 times, so the field will be 4 times 4 mu 0 I by 2R. Now, both the fields are in what direction? Both the fields are in same direction. Therefore, opposite direction. One is towards P, other is towards Q. We have to calculate net. Net will be 3 mu 0 I 4 root 2R, and that is towards Q, because field due to Q is more in magnitude, because current is more. So answer is coming to be 3 mu 0 I 4 root 2R. So again, second problem coming based upon the magnetic field acting on the axis of a coil. But here one thing, not only remembering the formula, one more aspect was very important here. What aspect was very important here? The important here it is a direction of current flow. Here we are using the clock rule. From looking into the coil P, current is clockwise, magnetic field is getting into it, that is towards P. But second case, current magnetic field is towards Q and it is 4 times bigger. Then when I take the net field, I have to take the difference of it. Q will be dominating and that comes to be 3 mu 0 I by 4 root 2 R. Then answer is coming to be first one. We go to the next question. Look, a moving coil galvanometer of resistance 100 ohms, full scale deflection. Yes, again, they are regularly maintaining the question based upon ammeter and voltmeter. Look here, let us go to the explanation, that will be better, saving time. You know, here full deflection current is 1 milliampere. We call it by the name IG. IG is 1 milliampere. Okay, IG is 1 milliampere. Correct? Yes. Now we have to read up to how much current? 5 milliampere. So if 5 milliampere current is coming, better I draw a diagram. This is the shunt resistance. This is galvanometer resistance. Galvanometer resistance is given to be how many? Is 100 ohms. And full deflection current permitted is 1 milliampere. Current coming is 5 milliampere. Therefore, current should be bypassed through the shunt will be 4 milliampere. And in galvanometer converting ammeter problems, we don't remember any special formula. Only one thing we have to remember, shunt and galvanometer are in parallel. So potential difference across shunt is equal to potential difference across galvanometer. Potential difference across galvanometer is IG, RG. Potential difference across shunt is I minus IG. That we know IG is 1, RG is 100, and 1 into 100 is equal to 4 into S. S is coming to be 25 ohms. And the answer is coming to be 3. Answer is coming to be 3. Yes. Now, come to the next question. Next question. Come on. A short magnet is placed at an angle 30 degree with external field of 800 Gauss. Experiences a torque of 0.036 Newton meter. Work done in moving it from most stable state to most unstable state. Okay, we can go to the explanation. It is clearly given to you. Yes, look, the torque experienced by the magnetic dipole formula is mb sine theta, and that is given to be 0.016 Newton, and 0.016 is mb sine 30. We are getting mb as 0.032 joules. From this calculation, sine 30 is half, 0.5, you will be getting mb as 0.03. So here we don't require magnetic field value and you don't require magnetic moment value, because you are directly getting mb. mb we got it as 0.032. Now work done in this, a ready-made formula. Actually, instead of this much explanation, there is a ready-made formula. Work done in rotating a dipole from what is mentioned here, most stable position, that is an equilibrium position, to most unstable state, it is in 180 degree. There is a ready-made formula, mb into cos theta 1 minus cos theta 2. Cos theta 1 is cos 01, cos theta 2 is 180, cos 180 is minus 1. So minus or minus will become what? 2. It will be 2 mb. 2 mb. Answer will be 2 mb, isn't it? And 2 mb is given to be how much? 60.064 is the value of mb. So it will be 2 into 0.032. That is coming to be 0.064. 64 into 10 to the power of minus 3 joules. Your question is alpha into 10 to the power of minus 3 joules. So is coming in place of alpha. 64 is coming. Here they have taken, here I have written same thing, no difference at all. Here they have taken the minus sign inside. So minus or minus will become plus. So it will become, this is a ready-made formula everybody remembers. From most stable state to unstable state, work done is, or another explanation I can give, the magnet is already in what position? Equilibrium position. It is turned through 180 degree. That is also basic formula to remember. The work done is given by 2mb. 2mb, that's the basic result. Or we can remember the formula mb into cos theta 1 minus cos theta 2. Theta 1 is initial position, theta 2 is initial position. We go to the next question. Come on. A current passing loop is contained in the form of an equilateral triangle of side 4 root 3 centimeter. Side is given to you 4 root 3 centimeter and current is 2 ampere. Magnetic field at the centroid is. This is a very common. Many even remember the answer. So better you to derive it out now, or if you are good enough in memorizing, it will be very good. Equilateral triangle center point, what will be the magnetic field? Look, what explanation we are giving. We go to the explanation for doing of this thing. It will be, look, equilateral triangle side, you know, magnetic field due to a one finite conductor. This is equilateral triangle. Due to one side, this distance we call d here, and this is distance from side to the centroid of an equilateral triangle. There is a ready-made formula. D is a by 2 root 3. A is the side of the equilateral triangle. Side of equilateral triangle is given to be 4 root 3. This is 4 root 3 by 2 root 3. That is 2 centimeter or 0.02 meter. Then formula is given by mu 0 I by d for sine 60, because equilateral triangle to the center, these angles are phi. This is phi 1, this is phi 2. And this separation is, I will draw it in a bigger one. This is an equilateral triangle. We want to find the field at the centroid. Oh, yes. This is the perpendicular distance. This is d. This is 60 degree. This is 60 degree. And dB worked out to be how much? 0.02 meter. Then what is the formula? Mu 0 I by 4 pi d sine 60 plus sine 60. This comes to be 10 to the power of minus 5 into root 3. And better to remember, yes, very good, due to one segment. And you know, we have to get the contribution of 3 segments. Don't verify whether field due to different segments are adding up or whatever happening, and make it into a point. If you take a point inside a loop, inside a current carrying loop, magnetic field due to all the parts of that loop will be in same direction. Either equilateral triangle, square, whatever it may be, within a point, field contribution due to each segment will be added up. And here all the segments are symmetric, all of same length. How much? 4 root 3. So magnetic field due to each segment will be same. Total field will be 3 times B1, that is 3 root 3 into 10 to the power of minus Tesla. And question it is asked that it is mu 0. Question is alpha into 10 to the power of minus 3. So who is in place of alpha? 3 root 3. 3 root 3 in place of alpha. Your answer is second in the option. Okay. We go to the next question regarding the 2 statements. First statement, you can go to the explanation. Look, you know, consider a ferromagnetic material. Assertion says individual atoms in the ferromagnetic material possesses magnetic dipole moment and interact with one another in such a way that spontaneously align themselves, forming domains. So, you know, this is a reason for domain formation. The ferromagnetic atoms have 2 and more unpaired electrons, or iron has got 4 unpaired electrons. As a result, magnetic moment of each ferromagnetic atom is much more than magnetic moment of a paramagnetic atom due to the presence of more number of unpaired electrons. And as each individual atom has more magnetic moment, they make their own treaty among them. They make some adjustment, and few of the atoms align in the same direction, forming a region of very large magnetic moment called as domain. In a ferromagnetic atom, a domain contains near about 10 to the power of 11 atoms. 10 to the power of 11 atoms are there. Means region of domain has got very large magnetic moment. And this is responsible for very large magnetic properties of ferromagnetic materials, high permeability. That is the assertion. Then what is the second statement? At high temperature, as temperature increases, the atoms in domains are looped up, and when temperature becomes above a temperature called Curie temperature, what happens? This domain feature will be lost. Domain feature will be lost. As a result, it will be losing almost not fully, almost all its magnetic property, because it becomes paramagnetic. Okay. So, in that point of view, at higher temperature, preferably above Curie temperature, ferromagnetic feature will be lost. They lose domain feature. So that statement is also correct. But one thing, it is not supporting what the first statement. First statement is telling that it has how an ferromagnetic material possesses high magnetic permeability. It explains how domain formation takes place. That's correct statement. But second statement is not supporting why it is gaining magnet. It is not supporting that. It is telling something else. That is, it may lose domain feature. That aspect is telling. It is not in tune with explaining the first assertion, first statement. So, assertion correct, reason correct, and it is not supporting, that is statement. Option 1 is correct one. We go to the next one. Look here, diagram is complete. Look here, a current carrying loop with a small discontinuity, and is it answer? Yes, answer part has got a diagram. Look, tell me, we have to calculate the magnetic field at O at the center of magnetic field at the center of what? The O, center O. Now tell me, magnetic field at the center is caused by this straight wire, long straight wire. Almost we can treat like an infinite long wire. At a point distant R, then directions are given. Exact y-axis is along, y and z-axis is in the plane of the loop, and x-axis is getting out of the plane of the loop. X-axis is getting out of the plane of the loop. Now, due to the state portion first field, that is due to state portion, I say B1, B straight portion, that is mu 0 I divided by due to straight portion, mu 0 I divided by 2R, and using this is getting out of the magnetic field region. Getting out means along positive x direction. Okay, B1 mu 0 I by 2 pi r, state portion mu 0 I by 2 pi r, mu 0 I divided by 2 pi r. Getting out of the plane of the paper means along positive direction. Now, second one, semicircular loop. Look, when you look into the loop, we are telling it third time. Looking into the loop, current is in clockwise direction clockwise direction, magnetic field is getting into it, and magnetic field is along negative x direction. Therefore, B2 will be mu 0 I divided by 2r circular portion and along negative x-axis. And one thing is clear, B2 is greater than B1 because B2 contains no pi in the denominator. B1 contains an additional term, additional factor pi in that. So B2 is greater than. So who will be dominating? B2 will be dominating. Getting into field will be dominating. Therefore, resultant field can be given by what? Mu 0 minus mu 0 I by 2r due to the circular loop, and this is plus mu 0 I by what? So it is coming to be, I have taken out mu 0 I by 2 pi r common, pi minus 1 I, because it is along negative, because minus is there. I have taken out minus mu 0 I by 2 pi r is taken out, pi is left over here, pi minus 1. So the correct option will be mu 0 I by 2 pi r, pi minus 1, negative sign is indicating it is getting into the plane of the paper. So option will be 2 according to your calculation. We go to the next one. A current carrying solenoid is placed vertically of mass and charge Q is released from rest. Particle moves along the axis of the solenoid. Note down it. Now, you know, if due to the coming of the particle, if there is some magnetic force acting on it, it will not be having a free fall. So acceleration will not be g. Let us go to the explanation part, is very clearly given. Look, so magnetic field inside solenoid is along the axis. Or charged particle is also released. It is moves down along the axis. As a result, no magnetic force Q is equal to V cross B. V and B are along the axis. V and B are in same direction. Therefore, net force on the charged particle will be 0. So due to the magnetic process, since the charged particle is coming along the axis, coming along the direction of magnetic field produced by the solenoid, there will be any magnetic force acting on it. So it is still have a free fall. So its acceleration will be how much? G only. So in your options you can see in the paper. No, what is asked? Yes, options are there. Acceleration is G. That is second one.